All right, let's go ahead and go through the answer to our warm-up today. So we have determine the volume of the composite solid. Remember, composite solid means that it's two or more solid figures, so three-dimensional figures. Okay, we've got this capsule kind of looking thing, and we're going to be rounding our answer to the nearest tenth. Okay, all right, so a couple things I'm noticing. First of all, I've got a cylinder, like this shape right here, that's a cylinder. Okay, so I know I'm going to need to find the volume of my cylinder, and I'm just going to write down my formula so I don't forget. Pi times the radius squared times the height. Okay. Now I also notice that I have a hemisphere, so half, up here, and I also have a hemisphere down here. So if I have two hemispheres, that means I have one holosphere. I'm just kidding, it's called a sphere. Hemisphere, holosphere. Okay, I bet I made some of you laugh. Don't deny it. Some of you gave me a stupid little grin and were like, Mrs. Lee, that was dumb, but hey, I will take it anywhere. All right, so we know we're going to have to find our volume of the sphere. I'm going to write that equation formula here. So that one is pi times 4 times pi times the radius cubed divided by 3. I was getting ahead of myself. All right, so let's go ahead and write down some other information that we have because this one can be a little confusing. So the entire height is 12 centimeters, but that doesn't make the height 12 centimeters of our cylinder right here. We need the height of the cylinder. Okay. Reminder, in a sphere, from any point in the center to any point on the outside, that's considered a radius. So the quote-unquote height of that hemisphere is 3 centimeters. So that means from here to here is 3 centimeters. And then the same thing down here. It's the same hemisphere. So that means that the quote-unquote height there is also 3 centimeters. So if this piece is 3 centimeters and this piece is 3 centimeters, that means that this piece, the height of our cylinder, is going to be 6 centimeters because 3 plus 3 plus 6 equals a total of 12. If that was a little confusing, I understand. Maybe stop, rewind, and play it again, or just email me if you're still really just not understanding. Okay, so let's go ahead and put some information in. We're trying to find the volume of the cylinder first, or I am. Okay, my radius is the same as for the hemispheres. My radius is 3. And my height, as I just figured out, is 6. All right, 3 squared is 9. And 9 times 6 is 54. Okay, and let's see, so I need 54 times pi, 169.64. Since we're rounding to the nearest tenth, I'm going to go ahead and take this 4, and that means 4 and below, that means I'm going to keep the number. So 169.6 is the volume of my cylinder. Over here, the volume of my sphere. Okay, so I have 4 times pi. My radius is 3, just as it was with the other problem, and we're going to divide that by 3. Okay, so 4, leaving the pi, 3 cubed. Okay, I know what 3 cubed is, but I'm just going to use my calculator. So 3 cubed equals 27. Bingo. So 27. Don't forget to divide by 3. Sometimes we get going and we forget to put that in there. Okay, so now I'm going to take that 27 and multiply it by 4, which is 108. Okay, so what I did, in case you missed that, was multiply the 4 and the 27, okay, which gave me 108, and then times pi, and then divided by 3. Okay, now remember, I am going to get rid of this piece first. So I'm going to take my 108 and divide it by 3. Okay, so 108 divided by 3 equals 36. I have 36 times pi, so 36 times pi, 113.09. So I'm rounding to my nearest tenth. The 9 is 5 or above, so that means I'm going to give this 0 a shove to 1. So 113.1. In order to get the volume of the whole thing, I need to add everything together. So 169.6 and 113.1. Drop down that decimal. 6 plus 1 is 7. 9 plus 3 is 12. 8, 2. So the volume of the entire capsule shape is 282.7, and my label is centimeters cubed. There you go.